So Sumukh and Siddharth are saying they have completed week 1 and week 2 respectively. Okay, well. So okay, so what we'll do then? So I have come up with some questions, right? So I have taken some questions which covers approximately, more or less brief topics. Also, I have taken the questions from last year question paper, okay? Which which does, see, there are anyway you have to cover week 1 to week 12, right? So for this session, I have taken some questions which has been asked in previous year. Also, I have taken the questions like from those topics which are normally asking in the which has been asked in the last year question. I mean, previous year question. So what we'll do? Uh, so what we'll do? We can simply. I will go. I will share the questions with you in front of you. We can try to solve it, and accordingly, we will discuss the concept related to that particular question. Will that be fine to all of you?
Yes.
Okay. Well, okay. Thanks. Okay. So let me share my screen. Okay. So can you see my screen now? Well,
Yeah.
okay, yeah. So this is the first question which I have taken. Okay, so okay, so I'm going to give you some 2 minutes. Just read the question and let me know which option should be correct. Okay. I mean, anyway, you have seen. So basically, main question is which one of the following statement best describes the difference between population and sample. Okay. So whether sample is the entire group while population is a subset of the sample which is used to describe the parameters of sample, or sample and population are synonyms of each other, or population is the entire group while sample is the
C would
subset.
be the answer.
C option.
C option, right? Okay, well, fine. Okay, so I got 2 votes for option number C. Anybody else? Anything? Any other thought? Yes, no, nothing. Okay, B as well. B is saying okay. Okay, Bharat. Why B? Any reason behind that? Why do you think option B should be correct? No, no, no. That's not a reason. Synonym means, see. Synonym means you are going to use just like, for example, uh, you can say synonym is for something, right? You are going to, there are 2 words for same thing. Okay. So sample and population is not the same thing. Okay. Because see, sample sample is something. For example, okay, let me try to explain with some example itself. I will start with the definition, then I will let you know. Actually, option number C is the correct. Okay, these are not the synonyms of each other. First of all, this is the wrong. How I will let you know. Actually, population is what? So basically, population is nothing but as it, okay, this is the definition itself. So in normally, what is the population we are considering? So it's nothing but total population is the total collection of all the elements that we are interested in. Okay. So for example, this is called the population. For example, so option number C is the correct. Okay, let me write here itself. So population is what? Actually, I told you, right? The total collection of all the elements in which we are interested in. For example, let's say uh, You can simply say, suppose I'm saying percentage of, I'm interested to know percentage of all students in India, okay, who have passed their class 12th, okay, their class 12th exams, and let's say they are going for yesterday, let's say engineering, okay. So here population will be what? So here your population will be collection of all the students, all those students who have already passed their class 12th and they are going to study the engineering, right? Throughout the India. Okay. So this is something called population. Means we are going to collect all the elements in which we are interested in. And what is the sample basically? Sample is nothing but this is a subset of a population. Okay. For example, it is very tedious task or difficult task to do your study or do your analysis on all the students, right? There will be lots of students throughout the India. So what you can do, you can take a subset out of this population. Let's say you are going to take a subset of, let's say 200 students or some, let's say 500 students, okay? Then you are going to do your analysis or do your study based on this sample data. So so what you are going to do, you are going to perform your study based on a small subset, and accordingly after that whatever result you will get, and then you are going to make some inference or something about your population data set. Okay, for example, based on this you have calculated, uh, let's say you are interested to know the average marks, okay, and for example you got the average marks of those who are doing engineering after like after passing class 12th, and their average marks in first sem or first year year is, let's say 75. Then you can make a conclusion like on an average students are scoring 75 marks, those who are going to I mean those who are going to pursue engineering after class 12, something like that. So that's the different thing. So our main concern is to try to understand sample is nothing but this is the subset of my population, and population is nothing but the total collection of all the elements that we are interested in. Is it clear? Fine. Is it fine? Then we can proceed for the next. You can simply tell me, right, whether you are getting or not. Yes, no, anything. Okay. Okay. Manju. Okay. Thanks. Sir. Okay. Well, so let's come to by using the same like the above information, right? Information means the things which you have discussed. So question is saying a study has been conducted to examine whether the student who had applied for MA Triple E entrance exam in 2020 are willing to write the exam in coming week or not. A group of 10,000 students were randomly selected from the urban areas of India for this study. It is concluded that roughly 80% of the students want to write the exam. So based on this information, we have to give the answer for the sub questions. Sub questions are question number 2, 3, and 4. So what is the question number 2 is saying? Based on this information, you have to identify the sample and population. Okay. So information is this till this point. Tell me what is the sample and what will be your population. Okay.
B would be the answer.
B would be the answer. Okay, I got one vote for B.
Sorry, not B, D.
Okay, let's cancel B. Then let's come to the D. What about others? You can simply unmute. So Manju is also saying option number D. Okay. I got 2 votes for option number D. Anything else?
Sir, I also think it's D.
D. Okay, well. Okay, so as of now, I got the vote for option number D. Actually, option number D is the correct option. Okay, this is the correct one. Okay. So how? Because it's a clearly mentioned, right? So what is the what is the objective or what is the study? They are going to do the study to know, to examine whether the students who had applied for Amit Triple E entrance exam in 2020, whether they are going to write the exam or not. For this study, they have taken a sample of 10,000 students from the urban areas of India. Okay, so they have taken a subset of 10,000 students, right? So this will be your sample, and you can see simple. And what is the population? Population consists of the students from all across India. Okay, so population is what? It is a total collection of all the elements that in which we are interested in. So far, so good. Well, okay. Should we move to the next part? Okay. So this next question is identify the correct statement from the following. And it is saying aforementioned conclusion made on the basis of the sample is correct. And aforementioned conclusion is not correct because the sample is not a good representation of the sample. And sample is a good representation of the population. And none of the above. So these 4 options you have to choose which one is the correct. Should I go? Should I show you question or you are able to recall that? C. Okay, so rather than writing on the chat, you can simply unmute because I have to change the tab, so it's a little bit difficult for me. Whether you want to question or not. So this is the question. I mean, this is the information. I mean, and question is you have to find whether sample is a good representative of the population or not. Okay, so you can simply tell me which one is the should be correct.
Yes, sir. Option C, sir.
Option C.
Yeah, C would be
Okay.
the answer.
What is the option C? Sample is a good representation of the population. Okay, I got 2 votes for option number C. Anybody, any
I'll go with option B.
option B? Option B was Siddharth, right?
Yeah.
Okay, well. Who was for option number C? I think Manju and
Hari.
Hari. Okay, well. Okay, so what did you actually option number B is the correct. Okay, option C is not a correct. Tell me why did you select option number C? I mean, what was your thought? Just to know whether you got the idea or not. Okay.
Because option C is saying that's a good representation, but they've only taken the urban population under consideration. They've not
Okay.
taken the rural population.
Yes, Siddharth, that is the correct. Yeah. And Hari and Manju, what was your thought? You took option number C.
Yeah, I didn't notice that urban population.
Okay, okay. Yeah. That is something you have to see. Anyway, that is the sample, right? See, sample is there because what we are doing here, okay, if you see simply, let me go. So what they are doing, suppose there are all the students, right? Suppose this is the, for example, just assuming hypothetically, suppose there are some students from rural areas and there are some students from urban areas. Okay, what they have done, they have taken a sample of 10,000 students, right, from urban areas only, right? So this is the sample, right? That's not a problem. So, but main thing is we have to be focused whether my sample is a good representative for my population or not. So your sample is not a good representative for this because they have taken the samples only from urban areas. It will be good representative when they have taken, for example, 10,000 students randomly from urban and rural areas. Understood? Let me take another example. Suppose I'm saying there is a college, right? In a college, there are some, let's say, some 4 to 5 departments are there. Let's say some humanities departments is there, and some CS, and another department. Let's say you can take, let's say, electrical engineering department, and then let's say anything else, some chemistry department or something like that. There are some, these 4 departments are there in a university or in a college. For example, suppose you are an analyst and you want to know what is the average annual package, or what is the average performance of the students in this university or in this college. So for that, what you have done, suppose you have taken the students from, let's say, some 100 students or 200 students, okay, as per your convenience. Suppose you have taken students from, let's say, CS department and electrical department, okay, and you have calculated the, let's say, average marks is, let's say, 90, and you are in making inference like average performance of this college is, I mean, on an average students are scoring 90 marks, okay. So this is something, okay, so this is okay. First of all, this will be your sample, this will be my population. Now tell me, my your sample is a good representative of for this population data set or not? Yes, no,
No, sir.
no, right? Why?
It only considers electrical.
Yeah, is CS and electrical, right? So it will be good representative if they have selected the 100 students or 200 students randomly from all of these 4 departments. Okay, then your sample will be the good representative. Okay, fine. Is this fine?
Yes, sir.
Okay, yeah. So let's move to the next question. Question says, what can you say about the nature of your study? Whether your study is descriptive or whether your study is inferential. Okay. So, so this is your study. Tell me whether this is the descriptive study or inferential study. Okay.
Option B.
Option B means you are saying inferential, right?
This is inferential.
Well, 2 vote for option number B,
Inferential.
3 vote. Okay. Okay. Why is that inferential?
Because it's giving some conclusion for the.
Yeah.
Yeah. This is okay. Actually, by the name, if you see inferential means you are going to make some inference about your population, right? Yes or no? So simply you can see what they are doing. They have selected a sample of 10,000 students from the urban areas of India, right? For this study, and they have concluded they have done some analysis or something they have done, right? Whatever the required things they have done already, and after that they are making conclusion, right? Roughly 80% of the students wants to write the exam all over the India, right? So what they have done, they have made a conclusion based on this where it went? Yeah, 10,000 students for your population. Okay. So what is the descriptive or inferential? Let me describe a little bit. Maybe that will give you the idea. So descriptive statistics. Okay. So there are 2 types of basic statistics: descriptive and inferential. What is, I mean, these are 2 major branches of statistics, you can say. So in descriptive statistics, what we are doing is basically, this is a part of the statistics where we are basically, we are concerned, I mean, we have concern about, basically, you can say simply, we are concerning the description and summarization of data. Okay. Now, what is the meaning of description and summarization? Basically, so summarization means we are going to give a numerical or graphical summary, something. Okay, we can give numerical or graphical summary. Okay, graphical summary means we can simply say, let's say we are making a chart and or something like that, any pie chart, any bar chart. So basically summarization means, or you can also interpret to sum up the main points of something or main points of your data set. So what is the meaning of main points? So main points means simply you can say simply whatever data set you have, you can simply calculate. For example, I can say you can calculate the mean, you can tell me median, you can tell me the maximum, mod, or etc. Right? Okay. Is this some sort of idea? Is okay in descriptive statistics? What we are doing? Basically, we are going to describe my data set. Okay. Let me define the inference. Let me give you the definition of inference. Okay. Let me take an example. For example, suppose I took the example of this, right? This college part. Okay. Suppose in a college there are some students. Okay. So this is the population data set. Okay. For example, and there are 4 departments. I told you. Let's say humanities. Okay. Then CS, then electrical, and then English. Okay. Now, okay. So are you able to understand, right? Whatever I'm writing little bit fast. Is that all right for everyone?
Yes,
Oh,
sir.
so okay. Yeah. Okay. Thank you. So suppose this is given to you, and for example, you took a sample. Okay. You can take a sample also. Okay. Before taking sample, suppose this is the in that college. Suppose some, just assume hypothetically, some let's say some 5,000 students are there. Okay. Now you are interested to know the average performance or students performance in that college. Okay. So what you can do, okay, suppose I gave you data of some 5,000 student. Okay, all data to you. Then what are the something? So you can perform. Okay, so here descriptive statistics means you are going to describe or summarize your data set. So what is the meaning of data set? Suppose you have been given the marks of this 5,000 student. Then what are the things you can describe? First of all, giving summary means you can simply say there is some maximum marks, let's say 98, right? There is some minimum marks, right? Let's say some 25. You can say average marks is this, right? Let's say 75, something like that. Yes or no? You can give some, you can describe something about your data set, right? You can simply say median. Median means you can simply say median is half of, let's say you can simply say 50% of the population or students are scoring below 60 or above 60, something like that, something, whatever the numbers you will get. So this is something, whatever data set you have, you are going to describe or you are going to summarize for data set. Okay, you can make a pie chart for the regional no region wise distribution, like some students are from north, some students are from south. Let's say you can say x% students are from north, y% of students are from south in that college or something like that. So whatever data set you have, you can give this kind of summary or this kind of descriptions in front of someone. Yes or no? Right?
Yes, sir.
Okay. So this is meaning of the description, descriptive statistics. So this is your population data, all data. You can summarize your, you can give your descriptive statistics. You can perform your descriptive statistics on population data also. Apart from that, suppose out of 5,000, this is the population data, and you are not going to do the your analysis or all on whole data set. Then what you can do for your simplicity, suppose you took a sample of 500 students. Okay. Okay, suppose you took a you have selected some randomly 500 students from the all 4 departments. Okay, then okay, based on this 500 student, can you calculate the maximum marks? Right, I can calculate the minimum marks, I can calculate the average or whatever I'm interested in, right? I can make a pie chart accordingly, I can make a bar chart or something like that, right? Basically, I can give the some summary of these 500 students or not.
Yes, sir.
So basically, I can describe and I can summarize my data set. So this is something called descriptive statistics. So basically, whatever data set you have, right? Whatever data set you have, So whatever data set you have means it can be your population data set as well as sample data set, right? So now you can see I had 5,000 students. I can give the description about my this 5,000 students also, right? If I have 500 students, I will give the description of this some summary of my this 500 student data set. So basically, descriptive statistics I can perform on population data set as well as sample data set. So far, so good.
Yes, sir.
Well, okay.
Yes, sir.
Now come to the inferential statistics. Okay. So what we are okay in inferential statistics by the name, if you say it's a something inference, right? So here we are going to drawing, right, the conclusions, okay, from the sample about population. So this is the key difference. Inferential statistics, we are going to drawing the conclusions or we are going to make the inference, okay, from the sample about the population data, right? So inferential can be performed only on the sample data set, because based on that sample data set, I'm going to make some inference about population data set. Where apart from this, if you see descriptive statistics, I can perform on population data set as well as on sample data set. Means whatever data set you have, you can give the description or you can give the summary of data set. While in the inferential statistics, what we have to do, whatever the data set, whatever sample you have. For example, I'm going to take the above example. In that college, let's say 5,000 students are there, okay, and you took a sample of 500 students. Well, now, for example, you have calculated the average marks of these 500, you got, let's say, 75. Okay. Now, if you stop there, then you have done the description about your sample, right, based on your sample data. But if I'm going to make a conclusion that on an average in the university A, let's say this is university A or college A, students are scoring 75 marks, then what you have done here, you have inferred or you have made a conclusion based on this sample data set for your population data set. So this is something called inferential statistics. Okay, based on my sample data set, if I'm going to make the conclusion for my population data set, that is called the inferential statistics. Is this clear?
Yes, sir.
Yeah. So let's move to the next part. Okay. So this is the inferential statistics. Okay. So next question is this: Karthik wants to start a shoe production company for all the Indian market. So 1 second. Okay, fine. Yeah, no problem. So here it should be only 5 actually. This is not 6. Okay. No. So question is, Karthik wants to start a shoe production company for all the Indian market to analyze public preferences. He has a team of market researchers who conduct market research in 2 states, Andhra Pradesh and Maharashtra. Okay. These are the 2 states. The market research team prepares a form to collect the data, and collected data, I mean, they have collected some data, and which is shown is the this table itself. So based on the information, we have to give the question answer for the question number 5. Okay. So what is the question says? You have to identify which of the collected data is unstructured. Okay, whether name, shoe material, price range as suggestion, which are the unstructured. I'm going to table itself. Tell me.
Suggestions would be the unstructured.
Suggestions will be the unstructured. Okay. What about others?
Unstructured, sir.
Yeah. So unstructured is the question. Which one is the unstructured?
Suggestions, sir.
Suggestions. Okay. Yeah. Well, so actually suggestion is the unstructured data. basically, okay, so there are two something suggestion is the correct answer actually. So there are types of data. Okay. Okay. Before going to that, can you tell me what about what kind of variable or data is this price range? I mean, my question is okay. Let me explain you something. Then I will come to. So data, right? There are 2 to 3 top things in data. So there is something called structured and unstructured. Okay. So by the name itself, right? So structured means what? By the name, you can simply, I will tell you some basic difference between these things. So structured data is something which is clearly defined. Okay. So clearly defined and searchable kind of data. So searchable kind of data means if that is in any predefined manner, right? Or in a tabular form or in a standard form, right? Then I can easily search the information, right? While in unstructured data, they are usually not in, any clearly defined. They are normally stored in its native form, right? Format, okay? And you can simply say structured data is easy to search and analyze. I can simply I can easily search the things and I can analyze the things. And while unstructured data, it requires basically more effort or more work to process and understand. Okay. And another, you can simply say it's structured data in predefined manner. Okay. While unstructured data is variety of formats. Okay. Variety of formats. For example, if you see here itself, so here you can see suggestions are they are stored in its native format, right? There is not any predefined manner or it's suppose I ask to you to choose the or tell me the where for which person or which person have given the suggestions as flexible. And so what you have to do, you have to go to each, right? You have to see each suggestion and then you can tell me Yamini gave the suggestion regarding flexible and all. Yes or no? So it will require more work. For example, let me take another example. Maybe that will give you the more idea. For example, suppose I'm saying Ram is a student, okay, of class 12th, and he is from, let's say, Delhi, and his marks in class 11th is, let's say, 98%, and his contact number is, let's say, 7923, something like that. And in the continuation of this, suppose I'm writing Sunil is a student of class 11th, and let's say he is from Chennai, and his contact number is, let's say, 9956 something. And again I'm saying, let's say Suman is a student of class 12th, and she is from, let's say, Bangalore, and her contact number is something 8928, something like that, for him. Now suppose I will ask what kind of this data looks like. I will ask, tell me the contact number of Suman. Then what you have to do, it will require more work to analyze or extract that information or not. You have to go line by line or word by word. Then you will tell me, yeah, contact number of Suman is 8928, something like that. Yes or no?
Yes, sir.
Correct. So this is, you can see, this data is stored in its native format, not any predefined manner, not in a standard form. instead of this, suppose this data is the same data. If it's written like that, suppose I'm saying student's name, okay, then class, then city, and then let's say contact number. Okay, then suppose this is the RAM, 12th, Delhi, some contact number, then Sunil, 11th, Chennai, some contact number, and then Suman, 12th, Bangalore, some contact number. Okay. Now, if this is the data, this is in any predefined standard form. If I will ask, tell me the contact number of Suman or Sunil, which will require the less effort, which is the easy to search, the analyze, easy to search and analyze the data.
Standard form, sir.
This is okay. This one. So this is something structured form, right, or standard form. Is this fine? Some sort of idea is okay. Well, it is clear to all.
Yes, sir.
Okay, so there is something another I will tell you, then I will move to that part. Actually, data has some other types also, right? So other types means normally data has two types. First one is called the categorical data, okay, and another is called the numerical data. Okay, so what is the categorical data? So categorical data, this data is normally qualitative in nature. And numerical data, these are the quantitative in nature. Okay, I will tell you the meaning of these two, don't worry. So what is the meaning of these two things actually? And within the numerical, there is two things called discrete and continuous. I will come to that part also, but let's try to understand first categorical and numerical. So categorical, as you can say, qualitative in data. So to understand the categorical data, is very first thing is on the categorical data, right? We cannot perform any meaningful mathematical operations. Okay. So basically, this is the key things to emphasize. Meaningful mathematical operation we cannot perform on categorical data. Even see, it's like, for example, what I mean, what I'm saying, gender. Okay. So gender, suppose it has two categories, female and male. Okay. So for these two category, can you perform any meaningful math? First of all, this is the categorical data, right? It's not in quantitative, it's a qualitative in nature, right? So can you perform any meaningful mathematical operation on this? Can you add f plus m or f minus m or f plus m divided by 2 something? Can we
No,
do
sir.
this?
No, sir.
We can't, right? Okay. If, okay, for example, suppose I'm going to see this categorical data also we can represent in numbers, but there should be, no, we cannot perform meaningful mathematical operation. For example, suppose I have coded female as 1, male as 0. Now, can I say 1 plus 0 is 1 here?
No, sir.
Never.
No, right? See, there is no meaning for this, right? Right? Because here what we are doing f plus m equal to m, right? That's not any, I mean, this is meaningless, right? So on categorical data, we cannot perform any meaningful mathematical operation, even those are in numbers. For example, suppose I'm saying, tell me the, for example, phone number. Okay. Suppose someone's phone number is 9823, something like that. Someone's phone number is 7988 or something like that. Can I perform any operation? Is this numerical data or categorical data? In numerical data, there is a different. I mean, the opposite. Opposite is means I can perform mathematical operation. Now tell me whether this is a categorical or numerical.
Categorical.
Why it's in numbers, right? So I can do the something, or it's categorical. That's correct. I mean, what should be the reason?
Cannot do any mathematical operations.
Yeah, we cannot do, right? Because you can't say this phone number is something more than this number, right? That is meaningless, right? Or you can't say addition of your contact number and mine contact number is equal to someone else's contact number, right? Same way, you can tell me Aadhaar card number.
Categorical, sir.
It's a categorical, right? Aadhaar card number, right? You can't say, right? You can't say Aadhaar card number, someone is Aadhaar card number is greater than yours or something like that. We cannot perform any meaningful mathematical operation. For example, pin code number, right? So this is also categorical, right? It's a region wise, right? You can't say pin code number is this greater than or less than or addition of something like this. So no meaningful mathematical operation, right? We can't do any meaningful mathematical operation, even though they looks like in numbers, right? So we have to take care of these things in our mind, okay? So while numerical data set is what? Numerical data set is nothing but we can perform meaningful mathematical operation, okay? So for example, I'm saying, let's say marks, right? And all, I can perform addition. I can say your marks is less than me, or your marks is greater than me, or addition, average, or something minimum, maximum. I can perform meaningful mathematical operation, right? Within numerical, there are two things called discrete and continuous, okay? So what is a discrete? Anyone? Any thought? You have seen the lectures, then what's your thought on discrete and continuous?
The whole numbers 1, 2, 3 like that.
Okay. Anybody else?
Continuous decimals.
Okay. Any I mean key region, because that's not a correct region. I can perform decimal values. I can as a discrete. Discrete is countable. Okay. Okay. So basically, see, in discrete, yeah, countable. So basically, discrete is something which we can count. Okay. Which we can count. For example, and one more thing you can keep in mind, it will take, I mean, it means discrete variable will take distinct values on real line. For example, okay, it's a countable. That is the key difference. Suppose I'm saying number of people in a room. I can count or not. Let's say some 5 people. Yes or no? Some 7 people. Okay. Then suppose I'm saying you can say number of students going to write an exam. Yes or no? So that will be again, so it's a countable, right? I can count, and it will take distinct value on the real line. Suppose this is your real line, it will take distinct value, right? Let's say 1, 2, 3, 4. It's a distinct value. So one key thing to identify in discrete, it will take distinct value, right? It cannot take any value between these two. Let's say these two. It cannot take any value. It cannot take any value between these two. It cannot take any value between these two intervals, something like that. Okay. While in the continuous, right? So continuous, we cannot count. It's not possible we can count. The only thing we have to measure. Okay? Continuous means you have to measure. You cannot count. That's the key difference. And it can take any values between an interval. Okay. For example, if I'm saying weight of person, okay, suppose weight of a person is something what you have to count or you have to measure.
Measure.
right? We have to measure because you can measure the weight in, let's say, 58 kilogram, right? 62 kilogram. Even though these are the in whole numbers, not in decimal, but we have to measure weight. We can't count the weight. Yes or no? Okay. Suppose I'm saying age of a person, then you have to measure or you have to count
Count.
age.
Age can be measured, right?
Age have to measure, right? Let's say 50, let's say you can simply say, right, 50 years 2 months, or you can simply say 15.2 years, right? You have to measure in years. Okay, tell me amount of milk. You have to measure or you have to count?
Measure.
Measure, right? Let's say 2 liter, right? Correct. 3 liter, something like that. Okay, speed of a vehicle,
Measure.
you have to measure in kilometer per hour. Let's say 40 kilometer per hour. Yes or no? Okay, so you have to measure. Is this fine? Now, and within, okay, one more thing I forgot to mention. Within categorical data, right, there are two kind of categorical data. Which you can order and you cannot order. Order means ranking. So here, can you do ordering?
No, sir.
No, we can't say, right? F is greater than M or M is greater than F, something like that, right? So in categorical data, order means, suppose I'm saying, for example, suppose I'm saying t-shirt sizes. Okay, then it's a small, medium, large, XL, and medium, something like that. Now, this is the ordinal or not,
This is ordinal.
right? We can
Ordinal.
order, right? We can do S is less than M is less than L is less than XL, or reverse, XL is greater than L is greater than M or greater than S. So this is the categorical data. We cannot perform any meaningful mathematical operation, but within the categorical data, I can do the ordering of this data set, right? So this is something called, maybe you have seen scales of measurement. So for this, it will be ordinal scale of measurement. Ordinal scale of measurement, where I can perform the ordering, and where if we are not able to perform ordering and it's a categorical data set, then it will call the nominal scale of measurement. Is this fine? Well,
Yes, sir.
so, okay, tell me, what about price range? What kind of variable is this?
Categorical.
Categorical. Within categorical, it's ordinal or nominal?
Ordinal.
Or
Ordinal, right? Because it's a order is there, right? Low, medium, high. Yes or
Yes,
no?
sir.
What about
Yes.
nominal or ordinal?
Sorry, sir.
What about purpose? Nominal or ordinal?
Nominal.
Nominal, right? We cannot do any ordering here, right? What about age?
Nominal.
Age.
Ordinal. Sorry, sir.
Age. It's a categorical or numerical?
Age is categorical.
Age is categorical.
Sorry, sir. It's numerical.
Numerical, right? You can do the meaningful mathematical operation, right? Age is a numerical, okay? And we know, see, as I told you, right, for categorical, we have two things, right? So anyway, we have two kind of data, right? So categorical data and numerical, right? So for categorical data, there are two things: nominal scale of measurement and ordinal scale of measurement. And for numerical, whenever I will have a numerical, there will be interval scale of measurement and ratio scale of measurement. So what's the key difference in interval and ratio? Let me see whether question is there or not. No, there is not any. Okay, there is question related to this. Okay, let me give you the idea. So in key difference in interval and ratio is that in interval absolute, there is one property. It's called absolute zero is not satisfied. Okay. While in ratio, absolute zero property is satisfied. So what is the meaning of absolute zero? Anyone? Did you get the idea from the lectures? Can you tell me if you get the idea? Yes, no, anything? Okay, if you didn't get right, you can simply tell me no, right? That's not a problem. Okay. So absolute zero means actually absence of particular thing. Okay. Means that particular thing is absent. What is the meaning of that? For example, if I'm saying zero pen, means there is no pen, right? If I will say zero number of person in a room, that is there is no person. Yes or no? If I will say zero number of phone in a shop, that means there is no phone in that shop. Yes or no? So zero means there is a meaning of zero. That means absence of that thing. That is the meaning of zero. In interval scale of measurement, this property is not satisfied. Means if I will say zero, but there is not absent, that thing is not absent. For example, suppose I will say 0 degree Celsius temperature. Okay, does this mean there is no temperature?
No.
No, right? There is some temperature, right? Where you can say this meaning of zero is not fulfilled, right? Yes or no?
Yes, sir.
So so that is the key difference in interval and ratio. In ratio, meaning of zero is satisfied, and due to this, if absolute zero property is not satisfied, only I can perform addition and subtraction, and in ratio I can perform addition, subtraction, multiplication, and division. Let me give you one example, and then I will move to the next part. Because, for example, I think in this temperature, I think minus 273 is the lowest, right? If I'm not wrong. Yes or no? I think that is the thing, right? Suppose this is a 20 degree and suppose this is the 40 degree, for example. Okay, I think minus 273 degrees is the lowest. You can correct it. Okay, now can you tell me if I will say the heat from or the amount of temperature from here to here, suppose from here to 20 is A and from here to 40 is B. Can I say B is the 2 times of A?
No, no, sir.
We can't say, right?
No.
Okay. Because of this absolute zero property. See, if absolute zero property is not fulfilled, right, it can take value below zero. You can say this is something hint or trick you can say about scales of measurement. Due to this, we cannot perform multiplication and division. While let's say I'm saying marks data. For example, suppose I'm saying 0 and maximum is 100. Let's say this is the 20, this is the 40. Suppose I'm saying there is a student who scored 20 marks and there is a student who scored 40 marks. Now, can I say B scored 2 times marks than A? Yes or no? Or I will
Yes.
say
Yeah.
A scored half of the marks than B, right? Can
Yes,
I
sir.
say? So because of this zero property, okay, it cannot take value below the zero if absolute zero property is fulfilled, because at zero it means absence of that thing, right? If zero is not fulfilled, that means it can take value below zero. Is this fine? All right.
Yes, sir.
Okay. One more thing is there called time series data and cross sectional data. Okay. So what does this mean? So time series data means you have collected the data over the time, and cross sectional data means data collection at same time. Okay. What is the meaning of overtime and same time? Let me give you example. Suppose overtime is you have collected the data of temperature, let's say in Chennai, throughout some day. Let's say in Chennai, let me write like this. Suppose you have collected the data on Sunday, let's say X degree Celsius. Monday, it was Y degree Celsius. Tuesday, it was Z degree Celsius and something like that till Saturday. Okay, so here you can see you collected the data at the same place through for over the time, right? Here time is days, right? Time can be anything. Time can be year. Here time can be days. Time can be month. Anything, right? Okay, and collection data at same time is, suppose you collected the data on Sunday throughout different cities, right? Let's say in Chennai, in Delhi, let's say in Punjab, and let's say in Haryana, something like that. So you can see time is the same, right? But on Sunday itself, you calculated the temperature data some throughout the different places. Yet places are different, but time is the same. Yet place is the same. Time is the different. Is this clear? Okay. So based on this, tell me the answer of this question.
Time series data.
Okay. What about others?
Time series.
Time series. I got 2 votes for time series. Right? Why time series? Yeah, time series is the correct. Okay. Why time series? Because they have collected the data over the time, right? So for all days from the past 3 months. Okay. So they have collected the data for Mumbai. So you can say place is the same, but they have collected data over the time. Okay. This is the time series data. If you come to the question number 7, tell me which scale of measurement is appropriate.
It's ordinal.
Okay, well, I got 1 vote for ordinal.
Ordinal, sir.
Ordinal. Okay, so basically, see, first of all, try to see whether what kind of variable is there, whether it's a categorical number. If it's categorical, then I will be having only 2 options, right? Nominal and ordinal. I mean, there is no need to think about interval and ratio, right? Because it's if it's categorical, I can't perform any addition, subtraction, multiplication, division. That means interval and ratio failed here, right? You have to think about nominal and ordinal. So basic thing is, if I'm able to order, or I'm able to do any ranking, any ordering among the categories, it will be ordinal. If I'm failed to do any ordering and all, it's a nominal. So here you can see it's ordinal, right? So first of all, this is the categorical data, right? And it's a order, right? So you can say simply not satisfied, then somewhat satisfied, then neutral, then satisfied. So it's a order. So it's a ordinal scale of measurement. Fine. So option number B is the correct. So far, so good. Is that all right
Yes,
till
sir.
now? Well,
Yes, sir.
okay. So let's move to the concepts of week 2. Okay. So this is the question, right? This is the one question. Hopefully you are getting the question is asking. So this is the number of deaths. So number of deaths means this is the frequency. Means for cancer 150. For relative frequency given to us T. Okay. What is the relative frequency? Anyone can remember? Relative frequency. Can you tell me what is the meaning of relative frequency? Yes, no. If you don't know, right, you can simply tell me. No. Accordingly, I will proceed. Okay, rather than waiting or should I?
Forgot.
Okay, no problem, no problem. Okay. So actually, frequency. Suppose okay, suppose just forget this column of the relative frequency. So this frequency, it gives you the count for each things, right? For each causes, cancer, accident, heart disease, right? So if you see, and if you'll see, but thing is that if see, I will be having the information about count, right? But what's the need of relative frequency? That might be a question, right? So relative frequency we are using for comparing two data set, right? So relative frequency is useful whenever we have to compare two data sets. Because okay, why we are doing, because sometimes it may possible, right, for let's say two different data, let's say data set A and data set B. Okay, for example, for this data set, let's say frequencies are same, let's say 5 some 3 and something like that. Frequencies can be same, but it's possible relative frequency are different, right? Yes or no? That is possible or not? Okay, so relative frequency is useful where we are we going to compare two data set, two different data set. How relative frequency is defined? By name, by name, if you see, it's a relative, so it's nothing but frequency divided by total frequency, or you can say frequency divided by total observations. Okay, so this is something our relative frequency is defined. Means if I will ask the relative frequency for cancer, or relative frequency, I'm just writing RF for the ith row or ith observation. This is nothing but frequency divided by frequency for the ith observation divided by n, and means total frequency or total observation. Means if you add all this, so this will give you the total observation. Okay, so this some sort of relative frequency definition is clear.
Yes, sir.
Okay, so this n means total observation means nothing but summation of all frequencies, right? That will give you the total observation. So by using this information, I'm going to give you some 2 to 3 minutes and let me know which option will be correct. So it is asking how many deaths happened in the city hospital in 2019. So you have to find the total number of deaths. So you have to find n. You have information like you know relative frequency for ith is nothing but frequency for that observation divided by total. By using this information, let me know which one is the correct. I'm going to give you 2 minutes. Okay.
D will be the answer, right?
Option D, sir.
D.
Hello, did you get the answer?
D.
D, it is.
Okay, why D?
Because there is no proper data for or finding total number of deaths, and in relative frequency also we don't sum up all the data.
Okay, well, okay. Okay, so D is the incorrect answer. I will let you know. Okay, so what is this? Ith means, okay, for anything, right? For ith, in any observation, right? For any row. Yes or no? Yes or no? Correct? So, okay, if you see, what is the relative frequency? We have to find the n, right? Can I write n as a frequency divided by relative frequency? Yes or no?
Yes, sir.
Okay. If this is the case and we know relative frequency, this is a definition. So if I can use anything, right? So for this case, right? Frequency is given to me, relative frequency is given to me. Can I use this or not? So 300 divided by 0.3 I will do. So it will give me 1000. On the same way, if you take this 250 divided by 0.25, again it will give you n as 1000 or not, right? So based
sir.
on that, and see how we got this frequency and relative frequency, there will be some n, right? Now is this clear? So 1000 is the correct answer. Okay, is this fine or not?
Yes, sir.
Okay, so from here I can say summation of all the frequency will give me the total observations. And can I say, what about if I will add all the relative frequency? What should it be? It should be equal to what? You can say this is in relative, right? This is something 0.3, 0.25, or if you multiply it by 100, then it will give you 25%, 30%. So what if I will add all the relative frequency? This will be some 17.5% if you are going to multiply it by 100. If you're not, then it will give you some 0.175, 0.25. What it will be? Summation. Just think, let me know.
100%, sir.
100%, right? 100% means 100 divided by 100. So summation of all relative frequency, can I say it should be equal to 1? Yes or no? So this
Yes,
is
sir.
something you can keep in your mind, right? This is the basic thing. Now, next question is you have to find the value of Z. Okay. So what is the Z? This is the Z. You have to find the value of Z. Okay. Can you tell me how will you proceed to find the value of Z? You have to use, you can use this information or this information.
Summation of RFI is equals to 1.
1. But in summation of RFI, there is one more thing we don't know, T, right?
Yes,
So what
sir.
we have to do? First, we have to calculate the value of T, right? Yes or no? Only then I can add remaining and then I can find the value of Z. Yes or no?
Sir.
Okay. So just calculate the value of Z, right? I will give you some 1 minute, 2 minutes. Okay. Just let me know. So why I'm asking with you people, because you may know how to calculate at the same time. Otherwise, see, one thing I can do, I can simply calculate and I can, right, I can move ahead, but that's not agenda. You should get some idea how to do these kind of things. Okay. So just tell me, let me know what is the value of Z. Are you calculating it, right? And waiting for your answer.
Can you go to the options?
Well, uh, yeah,
Option A.
option A. Okay. So, okay. So if you are trying, then I can wait. Or should I move? Shall I? Or okay. You are trying, right? So you can simply confirm on the same. If you're trying, then I can wait. I don't try for.
Option, sir.
Options are these things. Option A is the correct. Okay.
A.
A.
Option A. Yes.
Okay. So let me proceed. You can see, there is two things, right? We know this information. Summation of RFI is equal to 1, right? But before RFI is the relative frequency for each. So, but I need the value of T, right? And T is what? Relative frequency. And we know relative frequency is what? How I can calculate the value of T? This is the frequency, that is 150 divided by total. Total is 1000, right? So what will be this value of this things? 0.15,
Yes, sir.
right? So 0.15, right? So now we know the value of these things, right? So we have this is 0.15, this is 0.175, this is Z 0.25, 0.3, and we know summation of all relative frequencies equal to 1, right? So if you'll do 0.15 plus 0.175 plus Z plus 0.25 plus zero point 0.3 equal to 1. So from here, if you see value of Z equal to, it will be 0.125. Or you can do in other way. Other way means, see, you need to calculate the value of Z, right? You need the value of Y, correct? You can proceed with the value of Y, yes or no? But to know the value of Y means summation of all the frequencies equal to 1, total n, we need the value of X, right? So what is the value of X? How I can calculate the value of X? So this is frequency. So frequency will be what? So it's a relative frequency into n, right? Because see, relative frequency is nothing but frequency divided by n. So frequency will be what? Relative frequency into n, right? So what is the relative frequency for X? 0.175 into n is 1000. So it will be 175, right? So now you have 150, 175, and Y 250, 300. If you will add all this, what will the value of Y? There will be some value of Y, right? You can simply calculate. And then if you divide this Y divide by 1000, you will get the value of Z, right? Which is 0.125. Basically, value of Y will be 125. Okay. Are you getting what I'm trying to say here? So basically, we'll get 150 plus 175 plus Y plus 250 plus 300 equal to 1000. So from here, Y will be 125. And we know what is the value of Z. Z is the relative frequency for Y. So Z will be 125 divided by 1000, which is nothing but 1. Is this clear?
Yes, sir.
Okay, well. So let's move to the question number, next question. So next question says, if an analyst wants to represent the revenues of various companies using graphs, then which of the following graphical representations are most appropriate? We focus on this word, most appropriate for this purpose. So that analyst wants to represent the revenues. Okay. So options are these 10. Sorry, these 4. So tell me which which should be the correct option.
Option B, sir.
Okay, option B.
Option C.
Option C.
A.
Okay, I got one vote for option number A. Let me use some other color. Okay.
Option D.
Okay, option B.
No, D.
D.
Yeah.
Okay, just think, just a hint from my side. Just think why should option D should be correct. Okay, no for this. We will discuss. Okay. Any other thought? Okay. So option B and C is the correct. I will tell you why. It is asking about, first of all, most appropriate, right? So when pie chart is useful, anyone? I will come to the bar chart. Let me discuss first pie chart. Okay, before let me discuss bar chart so that because answer is bar chart. Actually, bar graph or bar chart is helpful when we are interested in the, I mean, when we are interested to show the represents the count of things, right? Yes or no? Right. And for example, suppose there is some college election is going on in college, and there are simple some, let's say 5 candidates are there, or let's say 4 candidates: candidate A, candidate B, candidate C, candidate D. So what you can do, You can simply make a bar chart and you can say how many votes they got, right? Yes or no? Okay. So whenever you are interested in the count, if you're interested to show represent the count of something, right, that will, in that scenario, bar chart is helpful. If you want to show like this, right, so this will give you a count, let's say some 10, some 5, or something 15, 20. And these things you can do in reverse order also. Okay, you can make A here, you can make B here, you can make C here, you can make D here, right? And on the axis you can count. Okay, so this is the case in the given in the question, right? A bar chart with a bar of each company on x-axis and length corresponding to its revenue in crore rupees or y-axis. Means x-axis, let's say these are the 4 companies. Okay, in revenue in crore, let's say 5 crore, 10 crore, 15 crore, and 20 crore and all. Same, you can do it reverse order also. You can simply represent the companies on y-axis and revenues on the axis also, right? So that's why B and C are the correct. Why not D is correct? Because it says a bar chart with minimum revenue as a baseline. So minimum revenue baseline, it will start basically 0. If you fix minimum revenue, right? So let's say from 3, or let's say from 5 minimum revenue. So this is the here missing baseline, right? Baseline is not missing. Sorry, baseline is missing here. Okay, baseline is not there. Baseline means this graph is not started with 0. So that's why it's not an appropriate graph. Okay. Now you got why option number D is not correct.
Yes, yes.
Okay.
I thought it would be 0 as.
No, it's about minimum revenue as a baseline, right? For example, suppose for company A, minimum revenue is 5 crore, right? Then we are starting with a 5 crore. That's not a good thing, right? It's
Yeah.
it will be misleading graph, right?
All right. Yes.
Yeah. And let's come to the option number A for pie chart. Actually, pie chart we are not going to use. I mean, it's not like we can't use, we can use, but it is asking for most appropriate. So actually, pie chart is appropriate when we are interested to show. So basically, you can simply say it's a graphs of it is a graphs that display percentage of a whole. Okay, whole means 100%. Okay, or you can say simply as if they were slices of a, I mean, it's basically graph means you can say it's simply circular graph. Okay, and in the circular graph it will it's not a correct circle. Okay, let me try to make it, just try to understand. Okay, suppose this circle, so there will be some slices. Okay, it's a parts of whole. Parts of whole means suppose this will be x% of a something, y% of something, z% of something, let's say w% of something. Okay, this is something parts of whole. For example, you can say there is a manufacturing company and you as a owner of that company, you might be interested to know there are some, let's say 4 products you are manufacturing in your company A, B, C and D, right? And you are interested to know in a particular year what is the sales percentage of for each product, right? You can simply say for A it's x%, for B it's y%, for C it's z%, for D it's w%. It's something here we are interested to show the parts of whole. Since it's a parts of whole, then addition of these all percentage, right, should be equal to how much? How much it should be if it's parts of something?
100, sir.
100, right? Yes. So sometimes we are making a round of error. Round of error means suppose sometimes this value is given to us 26.53 and this is 27 point, let's say 98. And sometimes for our simplicity we make it 26 and 28, something like that. If while rounding of error, if you will add all this, right, suppose this is something and this is something, so sometimes if you are going to round off the values, it may be more than 100 or less than 100, 99.7, it can be anything. So if that is something we are getting, that is called the rounding off error, right? Means we are going to round off the values and we are not getting as 100%. So we have to avoid this kind of errors. Okay, while in bar chart and all, right, sometimes we are started from not started from 0. That is something misleading graph, right? It's missing baseline, something called. Okay, so far so good. Are you getting some sort of idea? Yes or no?
Yes, sir.
Okay. Now tell me what is this? Which option should be correct?
Sir, I have one question.
Yeah, please.
Yeah. If we are we supposed to choose all the right answers, or if one
Yes.
answer is right?
Yeah. Suppose for it's the MSQ, right? Multiple select, right? If
Yes,
you
yes.
suppose B and C, if you selected B and C, you will get the total marks. Okay. For example, this question has the weightage of 3 marks. You will get 3 marks. For example, you selected only B, right, or
Yes.
only C. Okay, you will get 1.5 marks, but it should be the correct one of the correct. For example, you
Okay.
selected A, B, and C, in which B and C are correct, A is incorrect. You will get the 0 marks because you
Okay,
have
sir.
attempted incorrect option. Okay.
Okay, sir.
Okay. Yeah. Yeah. So which option should be correct for this question number 11? Mean, median, mode. You have to use the information about nominal and ordinal data like it's a categorical data, right? First of all. So can I perform something? You have to think, you have to apply the concepts
Mode
of
mode can be done,
Mode,
right?
mode, sir.
mode. Okay. Mode can be done, right? What about median? Median, can you perform median?
No, sir.
Why?
Mm.
Actually, see,
Because for an example, if we take
We can,
male and female, we can divide them, right?
we can't divide, and actually, median is something.
also
Okay. First of all,
order,
mean.
order is better.
Yeah.
You know,
Yeah.
me-
Actually, mean is
median.
something we can't do for nominal ordinal because mean requires the mathematical, right? Mathematical operation. And for nominal and ordinal data, it is not possible, first of all. In median, what median does, it divides the data in two equal parts, right? Okay. So if you have nominal data, right? Let's say your data of female, female, male, male, female. Can I order these things?
No.
No, we can't perform median. Suppose I have t-shirt sizes. For example, let's say I have S, S, M, L, XL or something like that. Okay. Can I order this one?
Yes.
So it can I can write SS, medium, large, and XL. So here I can find the median, right? Which divides the data into two equal parts? M, right? Yes or no? So here median is M, M size t-shirt. Okay, because this divides the data in two equal parts. You can see. So actually, median is for defined only for ordinal data set, while mod is defined for ordinal and nominal. Because here mod is how, what is the mod which occur more frequently? Yeah, mod means what? The something which occurs more
F.
number of times, right?
More frequently. More frequently. Yes.
So what should be the answer?
F.
F, right? And what about this? This data mod is which is occurring more number of times?
S.
S, right? So here you can see mod is defined for nominal as well as for ordinal, while median is defined for ordinal data only. In case of categorical, anyway, median and mean is defined, mean, median, and mod all are defined for numerical data set. Okay. In terms of nominal and ordinal, uh, median is defined for ordinal only, mod is defined for nominal as well as ordinal. Is this all right?
Yes, sir.
Okay. Right. So let's move to the next part. So okay, so you have to see this question and you have to give the answer. Okay, so question is this part, right? So there is a share of the Indian telecom market, it's plotted in this pie chart. Okay, you have to give the, based on this information, you have to choose the correct options. Okay, so options are: pie chart is not misleading, pie chart is misleading, pie chart has round off errors, slices of pie chart do not add up to 100, and mod of the data set is Reliance Jio. Okay, so tell me which option is the correct. Are you able to see? This is the 37%. Okay, this is 27%, this is 9%, this is 27%. Okay. So question is this misleading or not? First of all, what is the meaning of misleading here?
Can maybe the total is not 100 or more than.
No, in case of misleading, yeah, misleading is suppose the actually what is the meaning of area, principal, and misleading slices, right? It should be the means it should represent the area occupied by a particular part, right? It should represent the amount of data. For example, suppose just assume this 27 I have represented at 9%, right? And this as a 27%. Then this is something misleading, right?
Okay, sir.
Understood? And misleading is also right that you can consider as 100. Now just consider that part.
This is not misleading.
This is not misleading.
No.
Okay.
Can you go down?
Okay.
Uh,
Whether is
the
round
mode
of
of
errors or not.
I think mode of the data set is line 0. It's the 37%, right?
Okay. Yes.
So can you go down? So yeah, E would
It
be
has
the right answer.
A and
is
E is the right answer. Because D says slices of the pie should, do not add up to 100%, but it's added to 100%. Right? You can add up to 100%, right? Mod is 37% because this is the widest slice, right? Okay. So in case of pie chart, right, then mod will represent the widest slice. And in case of bar chart, which has the longest bar, right? For example, here you can see what is the mod? Mod is the D, right? Yes or no? Because
yes,
this
sir.
is occurring more number. Yeah. Now, for example, suppose I'm saying instead of 9%, just assume, okay? Just assume I'm saying this is the X%, 9% not given to you. And I ask what is the value of X? How will you find?
100 minus rest of.
some
100 minus something, right? If I will say, suppose total is 1000, okay, or let's say total is 100, total number of shares is let's say something 100, then what is the number of shares sold by Reliance Jio or something like that? In numbers, I'm talking about numbers. Total is 100, for example, then what is the shares by Reliance number in numbers?
37.
37, right? You can simply multiply, right? That is something basic, something you can keep in your mind. Okay, so that is something. If you are able to do this, that means you will be able to do a questions in your exam. Okay, that is something hint or you can say important kind of thing. So this is well fine. Okay. One last question from this week 2. Okay. So by observing this graph, tell me which option should be correct.
So B.
And B, sir.
B.
B.
Okay. Yeah. So B is the correct because baseline doesn't start from at a 0. So B is the correct. Okay. So and one more thing I forgot to mention. If we have ordinal data, right? So we have to keep the order in the bar chart. Okay. For example, you are going to make a chart of bar chart for t-shirt sizes, right? Then what you have to do? The first bar should be of your S size t-shirt. Then second M. It can then L. Then extra large. Okay, this something you have to maintain the order. You can do in reverse order also. You can mention, you can make a bar, first bar chart for XL, then large, then medium, then small. Why I'm emphasizing on order? Because that is the main characteristics of your ordinal data set, right? Because that is something we have to keep, we have to maintain the order, right? Well understood. Okay,
For
so
for what or sir,
yeah,
for what or other examples we have to keep that maintain that bar chart like that. For
sorry,
example,
could you repeat?
bar chart to be maintained like small, medium, large, and Excel. For
Any,
other
yeah,
for a,
any ordinal data. Suppose you have data of satisfied, okay, rating of the people, then more satisfied, right? Okay, something like that. So AD any ordinal data. Okay, you have to maintain the order, means first, I mean, you have to keep in order, that's all, your bars. Well,
Okay, sir. Okay, sir.
so let's
So
move.
is it the same like pyrotograph, sir? What is pyrotograph? What is the difference between this and that?
Okay, Bill, yeah. Thanks for the reminding. So actually, Pareto graph is nothing but, Pareto chart is nothing but another form of bar. But in Pareto chart, what we are doing the order of the frequency. Okay, so there is a difference in or maintain the order of the frequency. Okay, because order of the frequency means what do you mean by order of frequency? Suppose I will tell you, suppose there is candidate, right? Candidate A got, let's say, 10 votes. Okay, B got 5, C got 15, and D got, let's say, some uh, 20. Okay, for example, then you have to maintain the order. So in Pareto chart, because maintain the order, you can do in any way. Suppose you mentioned B, so B got 5, then A got 10, then C got 15, then D got 20. Okay, so 5, 10, 15, 20. So here you can see in a order, right? So here in order in the frequencies, not in here, right? Here this is not, because these are the candidate, right? We can't order the candidate, right? You can do in reverse order also. You can first draw for A, then C, then A, then B, then you will get the graph like this. Okay, sorry, like this. Understood? So this is, we have ordered in terms of frequency. Fine.
Okay, sir.
Is this clear, right? Okay.
Yes, sir.
Okay, fine. Okay, so let's move to the week 3 concepts. Okay. Okay, so I have taken some questions which have been asked, or okay, so this question was asked in last year question paper. Okay, and this one also. So I have taken that major important topics from there. Okay, if you have seen, okay, let me ask. How many of you covered the week 3?
I could cover it, sir.
Okay,
I
what
have
about,
seen a week 3.
okay, well, till which topics? What about others? Okay, accordingly, I will think whether I should directly jump to that concept, or I should give you some sort of idea about that concept. So that's why I'm asking. That's my agenda actually. So if you will tell me accordingly, I will be having some idea. What's the no one? Okay, well, fine. Week 3. Okay. Uh, okay. So okay, let me give you some sort of idea itself. If you are not. So, okay, so far we have seen in week 2 and all, right, about something more on categorical data and all, right? So let's see, in week 3, we are basically focusing on the numerical data. Okay, in numerical data, we know there are two kind of data, right? Discrete and continuous, right? This is something we have seen. Okay, so in continuous, we can basically plot for continuous data for histogram and all, right? So histogram is nothing but, in histogram we are making, it's a very popular graphical summary for continuous data. In histogram we are making, I'm not going to in depth, I'll tell you. So this is a continuation bar, it's an interval. Okay, let's say this A to B, one bar here, then another here, another here. So this is something called continuous graph. Okay, I mean, it's useful for continuous kind of data. Okay, because this will represent each interval. Okay, something like that. Major thing is, I will tell you, the called stem and leaf plot. Okay, so what is the stem and leaf plot? Is there nothing but, so this is the one question I will tell you, meaning of stem and leaf. Okay? So stem and leaf plot, it, so this is, this graph or this chart is something, is nothing but, it divides the data into two parts. Okay, two parts means first part will represent called stem and another part is called leaf. Okay, so this will divide that in two parts. For example, here it means, so key will be there. So this is the key. Key means how we have to interpret the data. So here 1/0 means it represents the 10 lakhs. I mean, this is the data of annual package of some offer to management studies in IT Madras. Okay, so here 10 means 10 lakh. So actually, one important thing from stem and leaf plot is all data are, if you observe carefully, in ascending order, right? How to interpret? So 1/0 means 10. So what is the next observation? 1/2 means it will be 12. Next observation will be 16. Okay. Then what will the next observation? Tell me.
25.
25.
25, 25, 25.
Well, fine. And then next
30, 32, 34,
32, 34. Then
and 41.
so basically, these are the observations which we have represented in the terms of stem and leaf plot. Okay, so if you have been given like this, right? So you have to interpret or you have to extract those observations. Okay, then you have to perform your whatever the question is there, right? So now let me tell you something after stem and leaf plot. So actually, something we have to perform our data called measures of central tendency. Okay. So measure of central tendency, by the name if you see, so under measures of central tendency there are two to three things are there. It's called mode, it's called median, it's called mean. Okay, what are these measures gives us? Basically they are measures, this gives us the this all things will give you the central value or center, you can say central idea about your data set. Okay, how we can do? For example, the data set you have 1, 2, 3, 4, 5. For example, these some, let's say 6. Well, so what is the mode of this data set? It's a 1. Okay, it will give you the which of the observations occurring more frequently, something like that. Okay, so and what is the median of this data set? Tell me. Okay, what is the median? Let me define. Median is, to calculate the median, it divides the data actually into two equal parts. For that, we have to first of all we have to see whether my number of I'm writing n, whether this is in even or odd. Well, okay, 3. Yeah, 3 is the answer, but I'm just going with the formula. I'm trying to see, tell you the formula. N means total number of observations in your data set. Okay. So we have to see whether this is even or odd. So first thing is, if N is odd, okay, then median of that data set will be, very first step is we have to arrange in ascending order. Don't forget this. People sometimes forget. We have to arrange in ascending order, and then we have to see whether it's odd or even, and then we have to apply the, if n is odd, then median will be n plus 1 by 2th observation for that data set. Now second is, if n is even, then median will be what? We have to take average of n by 2th observation and n by 2 plus 1th observation of my data set. For example, here, if you see, by coincidence, all observations are in ascending order, right? There is no need to arrange in ascending order. Yes or no? Well,
Yes.
so
Yes, sir.
what is the median? What is the value of n is? N is here 7, right?
7.
Which is odd. So what will the median? 7
7
plus
plus 1
1 by
divided by
2th observation. That means 4th observation. So 4th observation is what? In ascending order, it is, which is 3, right? You can see, right?
Yes,
First observation, second observation, third observation, fourth observation. So 3 is the median. Is this clear?
Yes, sir.
Yes, sir.
Now, I will tell you something about mean. I think which is more you are familiar. Mean is something, is nothing but we have to add all the observation divided by number of observations, right? Xi means all the observation. Is this fine? So we have to add all the observations, so, which means 1, 1, 2, 3, 4, 5, 6, right? So which is 1 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 divided by 7. So what is the value? It's 2, 2, 4, 3, 7, 7 and 4, 11, 11, 11, 22, right? 22 divided by 7. Yes or no? So this is something 3 point something, right? Then 3.14 something like that. Yeah, 22 divided by 7. Is this fine? This is something mean we are defining, okay? If this is clear, I will tell you something else now. Clear?
Yes, sir.
Sir.
Okay. Now come to one major property. Suppose I have the observations, let's say 1, 1, 2, 3, 4, 5. We had this observation. Okay, be focused what I'm trying to say. Suppose I want to add a constant to all the observations. Okay, then what will be my new data set? Let's suppose this is your xi. Suppose what will be your y here? What will be your new data set if you are going to add to all the observations?
3, 3,
3, 3,
3,
4,
3, 4,
then 6.
5,
Sorry,
6,
5,
5,
6, 7, and 8. And what was the mod for this data set? 1, right? Median was
3.
3. Mean was 3.14, right? So far so good. Now tell me, what is the mod for this data set?
3.
3. So can I write this 3 as a, let's say I'm just writing not a mod, let's say this is a new mod. New mod means mod of new data set. So can I write this 3 as a 1 plus 2? Okay, I will tell you what is the meaning. So
Yes,
this
sir.
one is what?
Yes.
Mod of old data set, right? Plus 2 is the constant which we have added, right?
Yes, sir.
Right? Now, what will be the new median? 5? Yes or no? See,
5.
equally divides,
sir.
right? Data set, right?
5. Yes.
Well, so if 5 is the median, oh, sorry. Can I write this 5 as a 3 plus
3
2,
plus. Yes, sir.
which is old mean, median, plus that constant? Yes or no? What will be the new mean? It will be something 5.14. Okay. You can calculate, you can cross check. Okay. So it's nothing but 3.14 plus 2, which is nothing but old mean plus that constant. So what I'm trying to say here, you can keep in your mind this property. Whenever you want to add observations to all the data set, I mean, add a constant to all the observations of your data set, then new mod will be, I mean, so you can simply write new mod will be old mod plus that constant, means you can simply say y as a x plus c. Okay, something like that. Let's say y mod equal to x mod, x means mod of old data set, something like that. So where it is important, for example, in a college or in a class, suppose there are some 50 students, right? And you know average of those average marks of those 50 students, let's say 60. Okay, now you know there was some discrepancy or some ambiguity in one of the question, and class teacher decided to give 2 marks to all the students for that particular question. And after that I asked you, tell me the average of the new marks of new data set, right? Then what you will do? Are you going to use, are you going to calculate, are you going to add all the observations then divide by 40, or you can simply apply this property, right?
Yes, sir.
Right? So this is something helpful in the some scenario. Is this all right? Well, so this is something if you want to add a constant, right? Suppose I'm saying if I want to multiply by a constant, okay, let's say 2 itself, Then what will be the observations? Your old data set was 1, 1, 2, 3, 4, 5, 6. If you want to multiply, then it will be 2, 2, 4, 6, 8, 10, and 12, right? Then what is the mod? It's a 2. This 2 is nothing but 1 into 2, right? That means old mod of old data set into that constant. Yes or no? What is the new
Yes.
median? New median is 6, which is nothing but 3 into 2. This is nothing but old median into that constant. What about new mean? Similarly, I can do new mean. For new mean, it will be old mean into that constant. Is this clear?
Yes, sir.
Okay.
Yes, sir.
Clear for all, right? Yeah. This is something you can keep in your mind because it's helpful whenever you have a very large data set and all. Okay. Now, now let me come to the part of called. So this is something it will give you the uh, uh, central idea about your data set. But what if this person, I mean, okay, this person, so there is something called measures of this person. Okay, before going to that, let me take one example. Suppose there is a college A and there is another college B, and I'm going to write, let's say, these 1, 2, 3, 4, 5. These are some packages of 5 students in 10 lakh. 10 lakh means this 10 lakh, this will 20 lakh, 30 lakh, 40 lakh, 50 lakh, something like that. And in college B, these are the packages of some 5 students. Can you tell me what is the average of this value? 1, 2, 3, 4, 5. If you calculate average or mean,
3, sir.
3. And what about college B?
3, sir.
3, right? Now, by seeing this value, right, only average, so can I say students are in both colleges, performance of students in both colleges are the same? Yes or no? Can I
No,
say this thing? Huh? Can I say, is it meaningful to say this? Just think, average is same, but if you see the observations, in reality, is it same?
No, sir, it's not same.
It's not same, right? Correct. See, on anyway, average is same. See here, measures of central tendency gives me the central idea. That's okay, right? 30 lakhs is there, but what if you can say in reality there is variability in data set, right? In reality, it's not, both are not consistent, right? In the both colleges, right?
Yes, sir.
Okay. So that is something we are going to study, measures of dispersion, right? So dispersion means what is the variability is there, right? What is the dispersion means, you can say variability of my data set. Well, or I can say no, spreadness of my data set, right? And etc., right? So there, see, for measures of central tendency we had mean, median, mode and all, but for measures of dispersion there is something called range. Okay, second is variance, and third one is standard deviation. Okay, well, now, so range is defined as something by the name. It's a range is something defined as maximum minus minimum. Okay, so basically range, basically, okay, what is the range of here? Range of packages, it's a 5 minus 1, right? Maximum is 5, minimum is 1. It's a 4, right? And here range is 0. Okay. But if you see in range, it includes only maximum value and minimum value. It doesn't involve all the observations, right? So that's why we are going to focus on the another measures, which is called variance. See, range is helpful, but this is sensitive to outliers. So what is the meaning of outliers? Outliers means extreme values. For example, your data set 1, 2, 3, 4, and 5. Okay. For this random data set, suppose your range is 4. For example, there is one outlier and instead of 5 you had 500, then what will be the range? Range will be 500 minus 1, that means 499, right? You can see a drastic change, right? Significant change, right? It's a very sensitive to outliers, and range doesn't include all the observations. It will talk about only maximum and minimum. So that's why we are moving to the next part, which is called the variance. Okay, how we can calculate the variance? It includes all the observations. So variance, there is, in variance there is two things called the population variance, okay, and sample variance. Well, so what is the difference in population variance sample? There is a just formula difference. So in population, where normally we are denoting as a sigma squared, so 1 upon n summation of I is equal to 1 to n xi minus x bar square. So from each observation, right? So n means total number of data observations in the data set. So here you can see each xi. So you had 1, 2, 3, 4, and 5, right? What is the x bar? X bar was 3. So what we are saying, if you focus on this quantity, we are going to take the deviation from each observation from its mean, right? We are going to say what is the spreadness or how much variability is there for each data set from its mean. Okay, so we have to do 1 minus 3 whole square plus 2 minus 3 whole square plus 3 minus 3 whole square plus 4 minus 4, 4 minus 3 whole square plus 5 minus 3 square divided by 5. Okay, and what is the sample variance actually? So there is a formula difference in sample variance. So sample variance we are denoting normally small s square 1 upon n. You can write here small n is also. So just we have to take care of whether okay, in sample square it's 1 upon n minus 1. Okay, summation I is equal to 1 to n xi minus x bar whole square. So we are not going into the derivation or reason behind this as of for this foundational level course, why we are using n minus 1 and n, you will read later. But this is the only difference is sample variance formula and population variance formula. We are going to use capital N, sorry, total number of observation, and we are going to use the n minus 1 here. Okay, it's something called unbiasedness and degree of freedom. That's if we are going to study, it will, I mean, we will be on different track. That's not our agenda here. Just try to see this. Okay, so this is something formulas of population variance and sample variance you can keep in your mind. Okay, the only difference is in the denominator is n and n minus 1. Is this all right so far?
Yes, sir.
Yes, sir.
There is something called standard deviation. Okay, okay, so standard deviation is nothing but square root of variance. Okay, for example, if I will say population standard deviation, right? So standard deviation, it will denote sigma. Square root of variance, it will be square root of 1 upon n summation I equal to 1 to n xi minus x bar square, and sample standard deviation, it will be small s, because we are going to take square root, so it will be 1 upon n minus 1 summation I is equal to 1 to n xi minus x bar square. Now there might be a question which can come in your mind. See, if we have calculated already this variability part, right? Then what's the important of taking just defining standard deviation by taking the square root, right? What's the importance? Anyone? Any thought? Why we are taking? What's the importance of taking square root, right? Anyway, if I were calculated, let's say variance is 4, then what's the importance of, I will explain, let's say this is standardization is 2. Then what's the importance? What's the role?
To match units, sir.
Yes, yeah, correct. That's the correct answer. Because if you suppose your exercise data is, let's say, year, age of some person, then variance you will get in year square, right? Correct, because this is the square. If you take square root, you will get the something in year, right? So it is easier to do the comparison and all, because it's in original unit of your, I mean, unit will be as same as the your original data set, right? Fine. So that is something importance of standard deviation. Now I will tell you something and then we'll move to the question part. Okay, See, we have seen to add the observation, what will be the effect on mean and all, right? The same thing. Okay, before to that, let me explain something. I will let you. If sigma square is 1 upon n, summation I is equal to 1 to n, xi minus x bar whole square, and sample variance is s square 1 upon n minus 1, summation I is equal to 1 to n, xi minus x bar whole square, right? Now, can I write this as n times of sigma square as summation I is equal to 1 to n xi minus x bar square? Just transformation. Yes or no? Are you getting
Yes, sir.
this one? Can I write this as a, let me put a line here. So n minus 1 times of s square as a summation of I is equal to 1 to n xi minus x bar square. Well, can I
Yes,
do
sir.
this or not? Right? I can do, right? Now, if you see, right hand side are equal, right, in both cases.
Yes, sir.
Can I say from where n sigma square is equal to n minus 1 s square or not?
Yes, sir.
Well, so this is something you can keep in your mind. For example, suppose n is given to you, sigma square is given to you, you've been asked what is the sample variance, you can simply tell me, right? Okay.
Yes, sir.
So this formula you can keep in your mind. Okay, so that is something hint, or you can say as a important, right? So if you okay, suppose s square is given to you, right? For example, I told you, suppose I'm saying n is given to you as, let's say, 10. Okay, and summation of I is equal to 1 to n, and xi minus x bar is square is, let's say, something m. Just assume what is the value of s square. You can simply tell me by using the formula n minus 1 summation I is equal to 1 to n xi minus x bar square. So m by 9 is the answer, right? Because n minus 1. So 10 minus 1. Okay, understood? So basically you have to do the some basic manipulation of the observation. Is this all right? Okay. Yes, no, fine.
Yes, sir.
Okay, well. Okay, so one more thing. Suppose you have been given the observation, formula booklet, no, Siddharth, this basic formula you have to keep in your mind actually. Okay. Okay, so questions and all I will share with you. Okay, I will share to the team. They will share this question PDF, this question PDF via mail itself. Okay, question PDF as well as the recording of the sessions. Okay. Now, so what I'm trying to say, explain here, if you want this thing which I have written here, if you are able to understand after this session, because something may be messed up, if you are able to understand, then I can upload this one, or else if it is okay, then we can ignore this annotated PDF from my side. Or do you want both one? If it
Yes, 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 sir. We need it.
will you be able to understand after this session, because something I have messed up, right? Will that be fine?
It's okay, sir. We can.
Okay, okay, well, okay. I will share both PDF with the team. Okay, let me discuss one concept. Then after that we can close if you want, or we can continue as per your convenience. Okay. Okay, so we have seen, right? So if I have some xi observations, old data set, right? If I want to add a constant c, then what will be my new data set? Let's say it will become xi plus c, right? I can be, let's say, 1 to n, and then let's say right. This is the right. And what will the mean? Y bar means mean of new data set. What should I write? Yeah, new mean was what? New mean was old mean plus c, right? Old mean means what will the mean? Normally we are denoting mean as a x bar, right? It will be x bar plus c. Yes or no?
Yes, sir.
Yes,
Okay,
sir.
let's come to the part about variance, whether what will the effect. So I'm going to discuss with the sample variance itself. You can do the same thing on population variance. Let's say I'm saying s square new. Okay, I'm going to define s square old. Old means, so what will the s square? It will be 1 upon n minus 1 summation I is equal to 1 to n xi minus x bar whole square, right? For this xi, right? This will be my sample variance, right? So s square nu will be what? 1 upon n minus 1 summation I is equal to 1 to n yi minus y bar whole square, right? Because my new data set is yi, right? This will be s square nu. Okay.
Yes, sir.
Okay. Let's try to understand something. 1 upon n minus 1 summation I is equal to 1. What is the yi? Yi you can see this is nothing but xi plus c. Yes or no? What
Yes,
will
sir.
the y bar? Y bar will be x bar plus c. Well, so I can do 1 upon n minus 1 summation of I to n xi plus c minus x bar minus c whole square. So c will get cancelled out. What I will get? 1 upon n minus 1 summation of I is equal to 1 to n xi minus x bar whole square. What is this? This is sample variance of old data set.
Yes,
Yes or no? So you can see variance of new data set and old data set is the same. So I can simply calculate adding a constant or subtracting a constant also, right? If you want to subtract c, so it will be minus c, and minus c minus minus will be plus c, so c will get cancelled out. So adding a constant or subtracting a constant will not affect on the variance. Is this clear? Why I can say this one, right?
Yes,
yes,
sir.
sir.
The same approach you can do for the population variance also, right? I will tell you the reason behind it. Okay. Okay. If you want to multiply by a constant, then if constant c, if I have old data set xi, then what will be the new data set? It will be xi times c, right? And what will be the mean? Mean will be x bar times c, right? We know new mean is nothing but mean of old data set into that constant, right? We have seen. Yes or no? In mathematical expression, I can write like this. Yes or no?
Yes, sir.
Okay.
Yes, sir.
Now let's do what will be the effect on this. Okay, tell me s square nu means variance of nu 1 upon n minus 1 summation of I is equal to 1 to n yi minus y bar whole square. This will be the variance of new data set, right? So what is the next thing? Summation of I is equal to 1 to n. What is the yi? It's a xi times c. What will be the y bar? X bar times c whole square, right? It will be 1 upon n minus 1. C I can take outside. So it will be c square, right? C square, it will be common, right? Because it's inside the square. It will be xi minus x bar whole square. So far, so this step is okay.
Yes, sir.
Okay. Well, so what I can write, so c square into 1 upon n minus 1 summation of I is equal to 1 to n xi minus x bar whole square. What is this? This is the variance of old data set, right? So what we have seen, if I'm going to add a constant, right, then variance of new data set will be same as old data set. If I want, I'm going to multiply by a constant, then variance of new data set will be square of that constant times variance of old data set. Is this clear?
Yes, sir.
So same you can perform for the population variance. The only difference it will be n. Doesn't matter. What about standard deviation of new data set? I'm just writing SD new, standard deviation of new data set. What will be? It will be standard deviation of old data set, right? Because we have to take the square root on both sides. Yes or no? Is this fine, right?
Yes, sir.
Okay. What about this case? Standard deviation of old data set, sorry, new data set, it will be
C.
C
Square.
times standard
Yes.
deviation of old data set.
Old.
Now, is this clear so far? Okay. Well, yes or no? Is this clear, right?
Yes, sir.
Now, so now based on this, you can use, if you want, I can do the calculation, or if you want to do, just do the calculation and tell me what is the average annual package of the student if each observation is doubled after subtracting 5 from it. So you have to apply this concept, the which we have used to add a constant multiplied by a constant. So what you can do, right? Okay, what are you meaning by this line? Adding a I mean, each observation is doubled after subtracting 5 from it. What do you get from it?
Multiplying with 2 and then subtracting.
Then or first subtracting, then multiplied by 2.
First subtract and then multiply with 2.
Correct? So what you can do? So there is two approach. Either you can subtract 2 and sorry 5, then multiply by 2 each observation, or else what you can do, you can simply calculate the mean of this package observation, and then suppose you got the mean as let's say x bar. Okay, then what will be the mean of new data set? Okay, what is the yi here? Yi here is we have to double the observations after subtracting 5 from it, right? No, not like this. It means basically we have to first subtract 5 from it, then we have to double, right? That is the meaning. Yes or no?
Yes, sir.
So
Yes,
what
sir.
will the y bar here? If you want to apply the formula, it will be that constant times x bar minus 5 or not? Yes or no?
Yes, sir.
So what you can do, just calculate the mean of this old data set and then subtract 5 and then tell me the and double and tell me the mean. Okay, would you like to do or should I do? If you want to do for your practice, I can give you some 3 to 4 minutes.
Yeah, it's done.
Okay, well, what is the mean?
I didn't calculate the mean. One second.
Then what you calculated then?
Mean is 10, so 10 minus 5, so 5 into 2, 10. Is that?
Mean is 10.
No, we wanted, mean of stem or what? Actually, I just joined, sir. Sorry.
Oh, okay. So it's here you have to calculate what is the average annual package of the students, right? If each observation is double after subtracting 5 from it. Okay.
Okay.
So these all are the packages, right? So you know how to interpret the stem, right? So 1/0 means 10 lakhs. So then 1/2 means 12, 16. So these are the observations we have to take. So we have to calculate the average annual package of these students if each observation is doubled after subtracting 5 feet. So there are two ways. First, you have to subtract 5, then you have to double, then you have to do for each observation, then you can calculate mean, or else you can calculate you can simply calculate the mean of this data set and you can apply the property.
Okay. Now I understood, sir. Sorry.
Well, okay, no problem.
40.
40 is the final answer you are talking, right?
Yeah, mean.
Okay. What about others?
40, sir.
40 is the final answer. What is the mean? Yeah, 40 is the correct answer. What is the mean of this old data set?
25, sir.
25, right? If you calculate the mean of this data, you got 25. Then what is the property says? So we have to subtract 5, right? Then it will be 20 and we have to double, which is 40. So 40 will be the correct answer. Is this fine? Right? So
Yes.
you can see what's the importance of those properties, right, which we have discussed. It's simply, right, see, we will be we can simply avoid we can simply simplifying the things, right? For simplifying this, for example, So it will be tedious task, right? It will take some time to subtract 5, then double, then calculate the mean, right? Something like that. What if for this? Tell me, what if the population variance of the given data if 5 is subtracted from each observations, right? So what you can tell me, we have seen there is no effect if I'm going to add a constant or subtract a constant, right? There will not be any effect on the variance set. Both variance of new data set and variance of old data set will be same. Yes or no? Well,
Yes, sir.
okay. So if I'm going to subtract 5 from each observation, there will not be any effect on the population variance, right? So what will
Yes,
the
sir.
population? So what we can do? You can simply calculate the population variance of this data set. Okay. So just tell me the observation to save the time. I will do on some. Can you tell me the observation? 10, 12, 16, 25, 25. Okay. Let me do here just for no to save our time. Okay. I will just show you what are the things. And then 30, 32, 34, 41. 30, 32, 34, and 41. So what is the population variance formula? You have to calculate the average, right? Xi minus x bar whole square, right? Okay. Then what is, you can see average is 25. So what we have to do next? Xi minus x bar whole square, right? Let me fix this. Yes or no? Then what we have to do? Next, we have to add all this. We have to do summation of xi minus x bar, right? And next is summation of xi minus x bar divided by number of observations. How many observations are there? 9, right? 9 or 10? 10, right? So you can see
Yeah,
88.6 is the population variance. And we know there is another formula in Google Sheet. We can directly apply var.p. It will give you the population variance. You can see it will again give you the 88.6. Both are the same. So we got population variance as a 88.6, right? Now tell me which option should be correct, 88.6 or 83.6?
88.6, sir.
88,
88.
right? Why not
88.
83.6?
Subtraction doesn't make an effect on.
Yeah, subtract and addition of a constant doesn't affect on the variance. Actually, then new variance will be same as old
old
variance.
variance.
Okay, that's why it's 88.6 is the correct answer. You can see C is the correct answer. Is this fine? Okay. So next question is based on week 4. We'll discuss in the next session. Okay. There is one concept. If you want, if you are able to, I mean, if you want, I can discuss it now, or else we can discuss in the next session. What should you prefer?
Shall we continue in next class?
Okay. So there is, yeah. Go ahead.
I mean, I'll be going to office now. That's why.
Office right now.
Yeah, night shift.
Okay. Well, what about others? So this is the one topic which is left for week 3. If you want, I can discuss it, or else we can discuss. We can
Both
start.
are fine, sir.
Sorry.
Both are fine.
Both are fine. Okay. Others, I will go with the maybe majority. If you want, if you are able to, if you want to sit for some minutes also, then we can discuss, or else we can close and we can start from the quartiles and percentile in the next session.
Or you can continue. I'll check it in
Continue.
the recording video.
Well, okay.
Because-
So Hari, what I will do, I
Yeah.
will not discuss more topics. I will just finish the week 3, right? Quartiles and percentile. Then from week 4 topics, we can start in the next session. Okay?
Yeah, that works. Yeah.
Okay. Okay. Well. Thank you. Thanks
you,
for
sir.
the cooperation. Yeah.
Thank you, sir.
Okay, so let me start with this quartiles and percentile, and then after that we will close, because from after this we will finish the week 3. Okay, then okay. Okay, so what is this percentile and meaning? I will just go with the percentile concept of percentile quartiles actually. So well, how many of you given the JEE exam, or have you heard about GRE and all? Maybe you have given the JEE exam and all, right?
Yes.
Yeah, that is for engineering and
Yeah, GRE for abroad and all. Okay, so maybe how you are saying the result? I mean, how they are giving result and all, how we are getting?
Percentile, sir.
Okay, suppose you are 90th percentile. That what is the meaning of 90th percentile?
98,
90th,
90,
90th.
90th. You are above 90% of people.
Correct. And means you are above 90% of the people, and there are yeah. Or else you can say 90% of people are below you, and
Below you.
remaining 10% people are above you.
Above.
Okay, that is the meaning of percentile. It's in 100 p percentile. For example, if I'm saying 25th percentile, right? So 25th percentile means let me draw it. Suppose this is 1 to 100, right? 1 to 100%. That means suppose this is 25th percentile. So that means 25% of the observation will be below this line, or remaining 75% will be greater or equal to this side. Okay. If I will say 75th percentile, or let's say 60th percentile, that means 60% of the observations will be below this, and remaining 40% of the observations will be above this. So this agenda is clear about percentile. Well, fine, right? So I will tell you
Suppose
the.
if it is, sir, one doubt. Suppose if I mean, is it same like 60 marks, right? Or else?
No, not a 60 marks. It's not about 100%, right?
Yeah.
So actually 60th percentile means, suppose you are at this point. That means suppose okay, suppose there are 60%. Suppose some 100 students gave the exam. Okay.
Yeah.
100 students, let's say, gave the, that means 60 students are below you.
Okay.
That doesn't mean you got 60 marks. Maybe you got 80 marks, and 60 students are below you, and remaining 40 students are above you. I mean 39. Okay.
Okay.
Well, okay, yeah. So there is some procedure to calculate this. Okay, I will just explain. So this actually this is something, it gives me about positions and all. So very first thing, how to calculate the percentage. First thing, we have to arrange the data, okay, in ascending order. Okay, we have to arrange the data. This is very first step. Second step is how to proceed. So we have to see N and P, right? N means number of observations, P means the which percentile I'm talking about. So what is the second step? Third step is we have to calculate the value of N into P. If so, this value, if value of N and P is, it may be integer, it may not be. If this is not an integer, okay, then what we have to see, we have to determine the smallest integer. Okay, if you're not getting the things, don't worry, I will take one example that will explain clearly. Smallest integer greater than this N into P. Okay, and next one is if NP is an integer. Okay, means multiplication of N into P is integer. Then what we have to take? We have to take the average of the values in positions NP and NP plus 1. Okay, what is the meaning of this? Suppose I'm going to say I've taken the observation 11, 12, 11, 14, 13, and 15, for example. Okay, what is the very first step? I have to arrange, right? Then what it will be? 11, 12, 13, 14, and 15. Then what is the next? We have to see N and P. Okay, so what is the N? N is 5. Let's say I'm interested to calculate the 25th percentile. So value of P will be 25 by 100, that means 0.25. So next is we have to calculate value of N into P. What is the N into P? 5 into 0.25, which is nothing but 1.25. So whether value of N into P is an integer or not?
No, it's not an integer.
It's not an integer, right? If it's not an integer, then what we have to check? we have to determine the smallest integer greater than NP. See, greater than 1.25 is what? It can be 2, it can be 3, it can be 4, right?
Yeah.
Right? So what is the smallest integer? This will be 2,
2.
right? So we have to take the second observations. What is the second observation in ascending order data set? Which is the 12. So 25th percentile of this data set will be 12. Okay. Don't take the observations from here. Okay. We have to first arrange the data set. Is this clear?
Yeah.
Yes,
Sir.
Suppose I'm saying we have to calculate the let's say 60th percentile. Then what will be the value of P? It will be 60 by 100. That means 0.6.
0.6.
What is the value of N into P? 5 into 0.6, which is? Which is?
3, sir.
3, right? If this is 3, this is in integer or decimal?
It's an integer.
It's in integer, right? We know if it's in integer, then what we have to take? We have to take average of the values in positions NP and NP plus 1. So
Yeah.
if NP is 3, then what we have to take? We have to take the
Third
average
and fourth
of,
average.
yeah, sorry, can you repeat?
Yeah, third and fourth average.
Correct. So position of average of third observations and fourth observations. Well, so what is the third observation? 13, 14 is fourth observation. So it will be 13 plus 14 divided by 2. So which is nothing but 27 divided by 2. So 13.5. Is this clear? Well, okay. Yes, no, right?
Yes, sir.
So next is called quartiles. Okay, what is this quartiles represents? So basically by the name you can say it's a quarter, right? So quarter means 1/4, right? Suppose you have data. So quartiles, what does quartiles? So whatever data set is, it divides the data in 4 equal parts. Okay, so this part, this part, this part. Just we have to do the scaling properly. Just assume these are the 4 equal parts. Okay. So first part, this is called the Q1, and this is called the Q2. This is called the Q3. So this Q1 represents the basically is called the first quartile. Okay. And Q2 called the second quartile, and Q3 is the third quartile. Okay, so I told you it divides data into 4 equal parts. That means what? This is the 25%, 25%, 25%, 25%. Yes or no? Yes or
Yes,
no?
sir.
What is the
Yes, sir.
Q1 first quartile means? It is the 25th percentile, right?
Yes.
25 percentile, right? What about Q2?
50.
50, right? What about Q3?
75.
Right? Because if you see for Q2, it will be 50% observation here and 50% observations here, right? So can you see? Can you tell me another name for Q2? It seems something maybe you have seen some previously. Is it median or not?
Median.
Right? Because median divides the data into 2 equal parts, right? Well, understood, right? Q3 is, you can see this 25% plus 25 plus 25. So it will cover 75th percentile, right? Yes or no? And remaining 25.
Yes,
Understood?
Yes, sir.
Okay. So for example, some data set is given to you 11, 12, 13. Okay, let me go to this data set, right? So 10, 12, 16. Let me write 10, 12, 16, 10. Okay, oh, this is the last page. Okay. What I can do, let's say 10, 12, 16, 25, 25, 25, 25, 25, 25, 30, 32, 34, and
34,
41. So you can see in stem and leaf plot, there observations are already in ascending order, right? There is no need to do an ascending order, right? So first step is already clear. What is the next? Suppose I'm asking you calculate the first quartile. It means 25th percentile. That means what is the N? 3, 3, 6, 3, 9,
10.
10, right?
10.
What is the P? What will be P if you want to calculate the first quartile? If you want to
Point-
calculate first quartile, that
Point
means
two.
25th percentile, right? So it will be 0.25. What is the next step? I have to calculate n into p.
P.
So 10 into 0.25 means 2.5.
2.5.
That means we have to take the next smallest, that is third observation.
Yes.
So 16 will be your Q1, right? Yes or no?
Yes.
What about Q2? To calculate the Q2, n is 10, p is 0.5. Then NP 10 into 0.5, that means 5. We have to take the average of 5 and 6, right?
Yes, sir.
So average of 5 and 6 means 25 plus 25 divided by 2, again 25, right? Yes or no? What about Q3? That means 75th percentile, right? So that will be 10 into 0.75, that means 7.5. That is 8th observation, right?
Yeah.
What is the 8th?
30.
32, right? So 32 will be Q3, right? Now are you able to do, right? Are you able to understand?
Yeah.
Okay, so there is something called after this IQR, which is called interquartile range. So that is defined as Q3 minus Q1. So Q3 is 32 minus Q1 is 16. So 16 will be IQR. This is formula of calculating IQR. So why I mentioned all these things in single? Because sometimes, suppose I have given the stem and leaf plot and I asked to you calculate the interquartile range. Then what you have to do? You have to calculate Q1, you have to calculate Q3, and you have to calculate the Q3 minus Q1. That will be the IQR of that test. Is this all right?
Yes, sir.
Okay. So well, so as we have discussed, so let's continue from the week 4 in the next session. I think that is on upcoming Thursday, right? Okay. Okay. Well, so I'm hoping you got the idea. Okay. So I will share this recording and PDF. I will share with the team. They will share via mail with you. Okay. Okay.
Okay.
Okay. Thanks.
sir.
Hope
How-
you got the idea. Yes. Yes. You are say something.
Yeah, so how many questions from statistics, sir?
I need to check around some 14 or 15 something.
Okay.
Okay. You can
So
see
how
from sorry.
average time for each questions will be how much, like if a 4-hour test?
It will not take that much time because you can see week 1 to 4, right? Week 1 and week 2, it's very straightforward. It's a theoretical thing, right? You can see, if you know the concept, you can directly select the ordinal or nominal and whatever is there, right? So something like that. So in we also we are we I mean normally we don't give the difficult calculation during the examination. We are giving something which let's say 10 plus 15 equal to 25 something. We are not going to give 3.2 plus 10.89 something like that. Okay. So there will be calculation. Normally we are avoiding calculation, that too much calculation, but without calculation it's not possible. But yeah, we are trying to give the simple numbers, simple calculation. Okay.
And we can use a calculator, right, sir?
Yes. Yeah.
Sir, is there any negative marking?
No.
Okay, sir.
So what kind of calculator is allowed in the
It's
exam?
a TCS scientific calculator, not any physical calculator. Calculator will be on your screen itself.
Okay.
Okay. Well, then we can wind up and we can start from the basic.
Actually, I have one doubt, sir.
Yes.
So, do
Yeah.
we need to bring our laptop to the center? Because actually, I'm in Dubai, so I'm not sure whether because today I had a system test, some SET test was there.
Well,
Just
okay.
to check my laptop configuration, everything. So
Hmm.
I just need to check whether I have to. I'm going to use the same laptop for the exam, or I will be having the written exam. Something I don't have any idea.
Okay, as per my knowledge, there will be system on your at your center. Okay, I don't think you to take your laptop, but for 100% surety, I will check with the ops team. I will confirm with you in the next session. Okay, but as per my knowledge, as of now, there is no need to bring your any system.
Okay, okay,
Okay,
sir.
well,
Okay,
well,
thank
yeah.
you so much.
Okay, okay then. Thanks all. I will share the things with you. Okay. Hopefully, I'm hoping you got the some idea till week 3. Okay. Okay.
Yes, sir. Thank you.
Okay. Well,
Thank you, sir.
thanks. Thanks all. Okay. Bye.
Thank you.
Thank you.